Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amin Firdaus bin Nur Azli. My metric number is AE180039. I will present for the activity 1 for exercise 1. So first we construct the circuit like in this presented circuit. We have two oscilloscope, one source with 100 volt peak source with 50 Hz frequency. Then we use a diode manufactured by Motorola, and then 3 multimeter. For the multimeter 1 is ammeter, and for the multimeter 2 and multimeter 3 it is set to be voltmeter. Okay, first from the multimeter, for the ammeter we got 308.345 milliampere, the current out for this circuit. And then the V out is 37.495. And then for the VAC, for the circuit, it is 70.693, which is measured by using the voltmeter 3. And for the V maximum, we need to change at the multimeter or voltmeter 2. We need to measure it in DC, so we will get 30.834 volt. So that's all the measurement for the parameter of activity 1, which is R load. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Ahmad Shukri eligible patent. My metric is AE180045. I will present the activity 2, which is RL load. In activity 2, there are 3 diode circuits that we must offset and record. For the first one, so when we run it, the result we will get like this. From here, we can see there are little bit lagging here. This is because the inductor is release the energy, the stored energy, because of reverse bias from diode. For the second circuit, we must add the inductor 50 millihenry. So we run. This is our result. As you can see, the lagging is become more lagging than previous circuit. This is because the increasing of number inductor. That means that the energy stored by 2 inductor is released when the diode is reverse bias. For the third diode circuit, we must add the addition diode. This diode is called freewheeling diode. For the third diode circuit, we must add the additional diode. This diode is called freewheeling diode. So we run. This is our result. As you can see from the waveform, the result is not lagging. This is because the energy that stored in the inductor is released and it flow here in this loop. This is because when diode D1 is reverse bias, so the energy that stored in this The energy that's stored in inductor will be flow at freewheeling diode, and we become a loop like this until diode D1 is forward bias. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Isakman. Today I'm going to show you about the rectifier bridge TB3. Okay, now we can see that in figure 1.3 we see that there are 4 diodes which is act as a rectifier and 2 resistors, which one is actually R load, the value is 100 ohm, and the other is a variable resistor which value is 1 ohm, and the variable resistor is connected to the ground. Okay, in this circuit we use the AC source which is in order to work on the circuit. Okay, this is the real connection of the diagram, which is the F3 phase power supply. The 4 bridge for diode, which is act as a bridge diode multimeter in order use to measure the voltage and the current, and this is the variable resistor, and this is oscilloscope in order to get the sine wave. Okay, this is the impedance. Okay, this is the connection circuit we use in the multi-sim, which is this is the multimeter we need connected in the parallel. This is the multimeter for the we measure the current. In order to work this multimeter, we need to connection in the series. Okay, this is the oscilloscope. We connect it into from the R1 before the resistor and then to the ground. Okay, this is the current that this is the result of the we measured, which is the VAC. We got 70.678 voltage, and the out we got 30.62 voltage. The next we got 62.105, and the current is we get is actually 306.187 milliampere. Okay, while the sine wave that we got from the full bridge is actually we got this form, which is the maximum is 62.105 voltage. Okay, that's it for me. Thank you.